Okay, now let us look at oxidation of alkenes. Oxidation of alkenes, we are going to look at two reactions. And the first reaction is when we add acidified or alkaline potassium permanganate to a solution of an alkene. So let us look at oxidation number one, which is addition of aqueous or acidic okay, there is a mistake here. It is addition of aqueous alkaline or acidic potassium permanganate. We are saying, I'll give you an example right away. When this happens, we form a diol. So the product is a diol. A diol is an alcohol with two OH groups. E.g., I'm saying if we have CH3, CH2, and I'm saying we can add aqueous potassium permanganate. So potassium permanganate, I can represent it with manganate ions. Valence of manganate ions is 1, so that is a manganate ion. Then here let me use alkaline. The OH means alkaline group, like from sodium hydroxide. And I'm saying when that happens, I form a diol. So the diol will go, one OH will go on carbon atom near the double bond, and the other OH will go on the carbon atom near the double bond. So the product is CH3, CH. I was telling you one OH group should come here. So this is OH, and the other OH group should also come there. So that is the diol product that we are talking about. But note that potassium permanganate can also be acidic. So when you use acidified potassium permanganate, in this case where there is OH here, you will have there a hydrogen ion. What is the name of this compound? It is propane, because these are 3 carbon atoms on straight chain, propane. Then this is on first carbon atom, 1, 2, diol. Propane 1, 2, diol. That is the name of that compound. Don't be confused. Potassium permanganate, the symbol is this. So the manganate ion is representing potassium permanganate. So if you want, instead of this manganate ion, you can write there potassium permanganate. It is still okay. Another oxidation reaction is called ozonolysis. It is called ozonolysis. Ozonolysis is the addition of ozone. It is addition of ozone. Addition of ozone. The symbol for ozone is O3. O3, not O2. That is the symbol for ozone. So when alkenes are ozonolyzed, when you add ozone to alkenes in presence of carbon tetrachloride as a solvent, you'll form an ozonide. And when that ozonide is hydrolyzed by water and zinc dust, it will form a carbonyl compound. A carbonyl compound is a compound where there is oxygen atom on the carbon atom directly, only one oxygen atom attached to the carbon atom. That is what we call a carbonyl compound. Let us look at an example. If I have CH3, CH2, CH, CH2, and I add ozone, told you that ozone is O3, and I add it in presence of carbon tetrachloride. This is carbon tetrachloride or tetrachloromethane. This is carbon tetrachloride. This is carbon, this is chlorine, this is carbon Cl4. Let me write it somehow properly. Carbon tetrachloride. I think that is better. This is 4. We are saying you are going to first form an ozonide. An ozonide is where these 3 oxygen atoms come in between, where there is a double bond, come between these 2 carbon atoms containing a double bond. So we form CH3, CH2, CH, then CH2, the double bond breaks, then the 3 oxygen atoms come between the carbon atoms like that. So this compound from here up to here is what we call an ozonide, where the 3 oxygen atoms have come between the carbon atoms containing the double bond, and the double bond has broken off. So we are saying when this ozonide is hydrolyzed with zinc dust, by zinc dust in presence of water. So this is zinc dust in presence of water. Hydrolysis is addition of water. Then we also need some ethanoic acid. The product, now the product is going to be carbonyl compound. So one carbonyl compound will be from here up to here, and the other carbonyl compound will be, each of these 2 will take an oxygen atom. This one from here up to here, and this one from there up to there will take an oxygen atom. So we shall have the one from here up to here it is going to be CH3, CH2, then C. It will be a carbonyl compound is where the oxygen is attached directly on the carbon. So one oxygen atom has come there, and the hydrogen is this one. See it? Hydrogen. Then plus the oxygen comes there. We have two hydrogens there. So this is one hydrogen. Here the carbon. So that is the product of ozonolysis, and that is how the reaction of ozonolysis takes place. That is how it takes place. I'm going to give you another example which involves ozonolysis. Just pay attention to this. Let's say you have CH3, CH3, then this is CH2, add ozone. This reaction is very common and very important of ozonolysis. We are saying in presence of carbon tetrachloride, we said you first form an ozonide where this carbon atom is a branch, where the three oxygen atoms are shared among the carbon atoms like that. So the three oxygen atoms come in between the carbon atoms containing a double bond. Then we are saying when you hydrolyze this zinc dust, zinc is just like a catalyst. Then in the presence of some ethanoic acid, you form each from here up to here will take one oxygen atom, so we are going to form CH3 plus, then this two will also take the other oxygen atoms, so we have hydrogen, and that is it. That is how the reaction of ozonolysis takes place.